Yay,
Okay,
it's
connecting to the
working.
cloud
Hey,
server.
got
And
it.
we are good to go. So again, this is the November meeting of AFSig. Welcome all. We only have one presentation tonight. There was no one volunteered to do a constellation. So maybe next month we'll have a constellation. But this month we're doing just the main presentation by Doug Smith, who's going to show us a bit of information about Venus. So Doug, if you'd like to share screen.
If this will work.
If this will work, I can make you a co-host.
Share screen. Okay.
There we go. All right. Thank you, Doug.
Has everybody got it?
I got it.
Okay. So tonight's presentation is basically a history of the exploration of Venus and some additional information to go along with it. Last month, our host, Mr. Ferris, gave a nice talk on Mars, and I thought I would do a bit of a talk on Venus. It has an interesting history to it in terms of the exploration, so I thought it would be fun. I wonder if I can put this in presentation mode.
Yeah, can you actually play this slideshow?
Well, it's not letting me do that the way I want to do that. There we go.
There we go.
Okay.
I don't know. My computer was running very slow tonight. I don't know. Maybe everybody else's.
I'll be slow and I'll wait a few seconds before I talk about each slide, and hopefully everybody's computer will catch up. So I always like to start my presentations now with a bit of humor. So here's a cute little comic from the far side. Astronomer's idea of a practical joke. Notice the guy's eyes are black, and the guys who are laughing must have put black stuff on the eyepiece.
He's holding a Sharpie in his hand.
Yes, that's there you go. All right, so go back long time. Go back before we sent spacecraft out to the planets. Go back to the 50s or even the 40s, maybe even the early 60s. We didn't know much about Venus. We knew very little. We knew it had an atmosphere because we could see, we had gotten views like this picture here that shows an atmospheric ring all the way around when it's unlike a moon where you don't have an atmosphere. You see the whole ring all the way around. There's an atmosphere there. Astronomers knew that way back in the 1800s. And as soon as they started taking photographs, they were able to take a photograph like this, although this is a recent photograph. But they knew it had an atmosphere. They didn't know much else. They knew how far away from the sun it was. They knew the length of its year. They knew its size. They had no idea how long its day was because they couldn't see any features on the surface to measure the length of the day. And they could only guess at the mass. They really didn't know what the mass was. So there was a lot of stuff we didn't know about Venus back then. As I said, it showed no surface features. So the obvious conclusion was it's completely covered by clouds. That created a mystery, if you like, opened the door to all kinds of speculation about what Venus was like underneath the clouds. A lot of astronomers and reputable scientists speculated that Venus might be very similar to Earth underneath those clouds. Being only 2/3 the distance from the sun as the Earth, it would be considerably warmer, but then they would say, well, with the perpetual cloud cover, might not be that much warmer, might be very similar to like a rainforest or a jungle on Earth. Okay, of course, they didn't know that the clouds were as thick as they are and that the atmosphere was as dense as we know it is today. They were assuming that the atmosphere was similar density to Earth's. I remember reading a science fiction story, and I think it was an Isaac Asimov story, about a race of people that lived on Venus, and it rained every day except one day. That special day was what the whole story was about. I also remember seeing artist rendition pictures in a Rand McNally atlas back in the 60s that showed Venus as a swampy kind of a place. Lots of imagination. Needless to say, the science fiction authors and filmmakers of the 50s and the 60s took big advantage of our absolute ignorance of the true surface conditions on Venus. Edgar Rice Burroughs' Carson of Venus book, you can just look at that cover. You could see, looks like a jungle, yeah, with some very strange trees. And then this one here, the middle one, Hidden Planet, again, looks something like a jungle. And maybe there's something there that looks like a dinosaur. I don't know. Yeah. And this one over here, Seas of Venus, David Drake. I don't know what that is, right? I actually saw that movie. I remember this movie, First Spaceship on Venus. That's an old black and white science fiction movie. I remember watching it. And then look at this one on the right, Cities on Venus. And this bottom one came from a paperback book, which I don't remember the title of, but that's Venus. So science fiction writers, authors, the people who made movies, they were having fun with Venus because we didn't know anything about it. Anybody remember this movie? Anybody even remember, could guess at the title? I think it's called Queen of Outer Space. Anyone recognize the actress standing in the middle? This is Zsa Zsa Gabor.
Really?
Yeah. That's an old film. Had a lot of fun with Venus. So like I said, our ignorance continued until into the 60s when we finally started launching spacecraft to Venus. Early spacecraft had a lot of problems, a lot of failures. I listed 4 of them there: Sputnik, a Mariner, Venera 1, and something called 2MV1. They all failed in flight or failed at launch. Interesting enough, I know this because I did a lot of work in orbital dynamics and stuff. It's actually a lot more difficult to put a spacecraft from Earth orbit to Venus than it is to go from Earth to Mars. Yeah. It's harder to go in towards the sun than to go out. Transfer orbits are more difficult. And that's actually one of the reasons NASA did a lot of work of did a lot of spacecraft, sent a lot of spacecraft out to Mars in the 60s and didn't spend a lot of time on Venus because it's more difficult. They took the easy, they picked Mars as their first target, or they picked the moon, but they picked Mars as the first outside planet to go to instead of trying to go to Venus. Interesting, the Russians did it the other way around. They went for Venus instead of Mars. So NASA's first spacecraft to go to Mars was Mariner 2. And if any of you remember the early 60s, that picture there is the Mariner 2 spacecraft, but it looks exactly like the Ranger spacecraft that we sent to the moon and crashed into the moon. And it's the same basically the same spacecraft as the Ranger satellites that we sent to the moon. This one was launched in 1962. We made no attempt to go into orbit. It was just a flyby. It flew by. Venus' closest approach was on December 14th, 1962, and it got as close as about 19,000 miles. It had a number of problems. They had to change launch vehicles before they launched satellite, and that forced them to change some of the instruments and make the satellite lighter. And one of the things that was removed was a TV camera, so we got no pictures. They had problems with telemetry during the flight. They had problems with one of the solar panels during the flight that required them to shut down some of the instruments. Most of the instruments that were there really didn't look at Venus. They looked at the environment around Venus, the solar wind, interplanetary magnetic field, and an assortment of items like that. The one instrument that did get used for observations of Venus was the infrared radiometer, and it was able to do several scans of Venus during the flyby and came back with that temperature of 500 degrees centigrade for a surface temperature of Venus, which surprised the heck out of everybody. That's 930 degrees Fahrenheit. They also, as they did a flyby, they were finally able to get a good grip on what the mass was. The flyby, the trajectory that came off the flyby was allowed them to get a good measurement of the mass. Finally, turns out it's very close to the Earth in terms of its mass. And as I said, the Russians decided to, while we were concentrating on the moon and Mars, the Russians decided they wanted to go for a different target, so they went after Venus. But they had a real tough time. They went through a period of what they call their black years. During the period from late 1962 through the end of 1965, they launched 8 different spacecraft at Venus, all of which failed in one way or another, either during launch or in flight. So they were having a rough time, but they kept at it. They finally got Veneer 3 to make it all the way to, and it was meant to be a lander. It was meant to go all the way to the surface of Venus. They knew nothing about how thick the atmosphere was, and they didn't really believe our Mariner 2 temperature data. They didn't believe it. Not all American scientists believed it at first. So the spacecraft, Veneer 3, was just a typical spacecraft. It was not designed for a great deal of pressure or a great deal of heat. Needless to say, it didn't last very long once it entered the atmosphere. It died out quickly. They didn't get a lot of data from it. The speculation is it overheated really fast. In 1967, we tried again with Mariner 5. It flew by Venus, got as close as 2,500 miles, did return data, but then lost its lock on the Earth, and we never reacquired it. So we didn't get much data. We did get a little, which we gave to the Russians when they did their Veneer 4 to try to help them. We cooperate in space stuff, even back then. So here's Veneer 4. Veneer 4 was launched in the middle of 1967, roughly within 2 days of when we launched Mariner 5. It arrived in October. It arrived at Venus in October of 67. The entry probe, which is the thing on the bottom picture there, was supposed to drop into the atmosphere and survive all the way to the surface. And then the rest of the spacecraft was going to stay in orbit and retrieve the data as a relay from the entry probe. Well, as I said, the Russians didn't believe the Mariner 2 data. So when they built this entry probe, they didn't build it to withstand heat or pressure. It probably got crushed long before it reached the surface. At this point, the Russians are starting to believe some of the measurements that were gave them from the mariners. They're starting to think that maybe 500 degrees centigrade is really what the temperature is. So 1969, they're starting to get really good at getting to Venus. The US is pretty much, we're not doing much with Venus. We're concentrating on Mars and the moon. 1969 is when we went to the moon. We're putting all our efforts into Apollo and so forth. The Russians are still sending spacecraft to Venus. They sent 3 of them in 1969. They're in 1970. Venera 5, 6, and 7. Venera's 5 and Venera 6 were basically exactly the same design as the Venera 4. And at this point now they're saying, well, we don't think the entry probes are going to make it to the surface, but they're going to operate for a little bit of time. We'll get some data from them. And they did. Both of those probes lasted about 50 minutes in the Venetian atmosphere before they got crushed or overheated. And so they got quite a bit of useful data out of those 2 satellites. Finally, Venera 7 was built to survive the pressure and temperature. There was a picture of it there, and you can see it's basically built like a bathysphere, something you would drop in the deep ocean. It's got thick walls, it's heavily insulated, you know, and now they're understanding what kinds of pressures and temperatures they have to deal with. It was launched in 1970, arrived in December. The probe actually made it all the way to the surface intact, but it rolled on its side. It rolled over on its side, and so they did not get much data from it. They did get enough data, though, to confirm the surface conditions, that the atmospheric pressure is like 100 times that on Earth, and that the temperatures are indeed in the neighborhood of 500 degrees centigrade. Venera 8. This was the first one that was an absolute total success. This one was launched in March of 1972, and the lander is the spherical object at the bottom of the picture there. It's, like I said, it's built like a bathysphere. The walls are 5-inch thick. They're heavily insulated. The Russians even pre-cooled it by carrying a tank of liquid nitrogen that they pumped into the lander right before the lander was ejected, and it cooled the lander down to -8 degrees centigrade, hoping that would allow it to last longer on the surface. It lasted for 50 minutes and 11 seconds after landing on the surface before it finally gave way to the temperature. It measured a surface temperature of 470 degrees centigrade, and it measured an atmospheric pressure of 90 atmospheres, 90 times the Earth's atmospheric pressure. To give you some idea what that pressure is, that's something like 13,000 pounds per square inch instead of the normal 14.7. or 1,300 pounds per square inch. That pressure is the same as being at a depth of 3,100 feet in the ocean, and that would crush any submarine hull except for your special built deep dive submersibles. So really thick atmosphere. It did not carry a camera, but it did have a radiometer, so it did a rough estimate of how much light there was, and it basically came to there's enough light to see. It's about the same as an overcast day on Earth, and the visibility is roughly 1 kilometer. And they also were able to measure that the clouds stopped at a very high altitude and the atmosphere was clear down to the surface. Now we decided to go back after we've been to the moon, and we sent Mariner 9 to Mars, so we're getting pretty good at what we're doing now. We decided to try to send another one back to Venus, so we sent Mariner 10. Mariner 10 was to be a flyby of Venus and also do 3 flybys of Mercury. And so we got it was a very successful mission. It arrived at Venus in February of 1974 and got within 3,500 miles at closest approach. It had a number of cameras, so we were able to take some pictures, and it had spectrometers and other data, images, instruments. And so again, we were able to confirm the temperature and the other information, but we finally got some nice pictures. The picture there on the left is a visible light picture from Mariner 10. And the picture on the right is a UV picture. And you can actually see some cloud structure in the picture on the right in the ultraviolets. And the spectrometer was able to give us some readings on the atmospheric composition. It's mostly carbon dioxide. And that matched what the Venera data had come back with. And that was it. We didn't go back to Venus again for a long time. The Russians kept going. They made Venus they like going to Venus. Meanwhile, we were going to Mars during this period, during 1978 and 1979, in that area. We were going back to Mars with Viking 1, Viking 2, and we were going to the outer planets with Voyager 1 and Voyager 2. During this same period, the Russians kept sending things to Venus. Venera 9 landed on Venus in October of 75. It managed to operate for 53 minutes. Since the atmosphere was so bloody thick like water, they realized they didn't need to have a parachute to reach the surface. They didn't need to parachute all the way down. And also the parachute, as it turns out, would melt from the heat. They found that out. But they had this thing called, they had an aeroshell. If you look in that picture up in the right corner there, that big flat ring around the top of the spacecraft is the aeroshell. And that would be deployed after the parachute was cut off. They would deploy that aeroshell, and that would provide enough drag to slow the spacecraft down because the atmosphere is so thick. It's like, you're like dropping through some very thick viscous fluid. And that would slow it down until it would reach touchdown. The carrier spacecraft that carried the Venera 9 went into orbit, and it stayed in operation for 2 months. And so they got ton of data, and they finally were able to take a picture on the surface. They had a panoramic camera. It was able to take one 180-degree picture. That's the picture at the bottom of the slide before the camera failed. I don't want that. Okay. The other thing Venera 9 was able to confirm, pardon me, I've got these automatic things that like to run on my computer sometimes. Get rid of them. There we go. The other thing that Venera 9 confirmed during its drop through the clouds was that the clouds contained hydrosulfuric acid and hydrochloric acid in the clouds, very unfriendly clouds. As I said, they went back 3 more times during that period from 75 to 78. They did Venera 10, Venera 11, Venera 12. These were all very successful. They all landed. They all operated for like an hour, got lots of data. Finally, they got color images. There's a couple of color images from Venera, I think that's Venera 10. And, you know, so you can see what Venus looks like on the surface. It's mostly basaltic plains covered with just a lot of flat basaltic rocks. We finally decided we'd go back in 1978. We sent back Pioneer Venus. We had an extra Pioneer chassis, literally an extra Pioneer satellite chassis lying around, and we built it up into this Pioneer Venus spacecraft that had an orbiter, that had a variety of instruments and would carry 4 probes. That's the bottom image. You can see the 4 probes. 1 very large probe, 3 smaller probes. One of the small probes was specifically designed to make it to the surface and take instrument readings on the surface. The other 3 probes, the large probe and 2 of the small probes, were just atmospheric probes, and we're just going to take data from the atmosphere. That mission went off perfectly. The day probe actually made it all the way to the surface and transmitted data from the surface for over an hour. The 3 atmospheric probes took lots of measurements of the atmosphere content and composition, and they did all their job. And the orbiter was still in operation in 1992. It operated for 14 years before it finally shut down. And then finally, like I said, the Russians had continued going to Venus. They sent additional spacecraft all the time. We finally went back again one more time in 1989 with Magellan. This was a huge spacecraft that was launched from the shuttle in cooperation with the European Space Agency. This spacecraft had a large, high-resolution radar imager that could penetrate the clouds and was used to map the entire surface of Venus at very high resolution. The Magellan got into orbit in 1990 and operated until 1994. And during that time, it mapped the surface 6 times, including a very high resolution mapping. And I got some sample of the images down here on the bottom that came back from the high resolution mapper. Since Magellan, there have been a few missions back to Venus and several flybys where we've used Venus as a gravity assist, but not a whole lot new has been learned, except something I'll talk about in a minute. And just so here's what we know from Venus now. We know that it's about 0.8. The mass is a little bit less than Earth. It's 0.815 Earth's mass. The radius is almost the same, 0.95. If you look at the image down there in the bottom right, there's the 4 rocky planets, terrestrial planets compared. There's Mercury on the left, Venus is the second one, Earth the third, and Mars is on the right. And you see that Venus and the Earth are almost exactly the same size, not quite. The density is almost the same as the Earth. The density of the Earth is 5.5 grams per cubic centimeter. The average density of Venus is 5.2 grams per cubic centimeter, so they're almost the same. The gravity at the surface is almost exactly the same as the Earth's gravity. It's 0.9 of the Earth's gravity. So if you just looked at that data, you'd say this planet is very Earth-like, which is why, until we went there with satellites, that a lot of people thought it would be very Earth-like because everything is very similar to Earth. But then you start looking at the stuff that we learned since we've sent satellites there. And there's a lot of, like one of the things we didn't know was how long the day was until we sent satellites there and started measuring it, because you can't see the surface features, so there's no way to figure out what the rotation is until you get there and can actually measure the rotation. Turns out the length of the day is equivalent to 243 days of Earth days, and it's retrograde. Venus is spinning the opposite direction of all the other planets on its axis. It's spinning backwards. The sun will rise in the west and set in the east. The length of year, it takes 224 days to go around the sun. So its day, its sidereal day, is actually longer than its year, which is an interesting feature. It has the most circular orbit. The eccentricity of its orbit is 0.0067. It is a good thing that Tycho Brahe did not tell Kepler to study Venus, and he told him to study Mars. Otherwise, Kepler may never have come up with his laws of planetary motion. And the fun stuff is the atmosphere. The average surface temperature is 475 degrees centigrade. The atmospheric pressure is 92 bar, 92 times the Earth's atmosphere, a staggering 1,350 pounds per square inch. The atmosphere is 96% carbon dioxide, 3.5% nitrogen, and some other trace elements. No water, no oxygen. The carbon dioxide is responsible for the high temperatures. It's a greenhouse effect in the extreme. The clouds, as was measured by various satellites, are composed of various sulfide, chloride, and fluoride compounds. If it precipitates, it's very possible it rains sulfuric acid. Venus has no evidence of tectonic activity, but it is covered with a large number of volcanic complexes, deep rifts, and basaltic plains. Carl Sagan once described Venus as the closest approximation to hell he could think of. A very unpleasant place to visit. Now, here's the new one. How about this one, folks? Life on Venus. Who would have thought? Back in 1967, Carl Sagan and Harold Marlitz actually proposed that life might exist in the clouds of Venus, up in the altitudes where the temperatures and the pressures are not so ridiculous. Nobody paid much attention to that when they learned how extreme the planet was, until very recently. September of this year, the James Clerk Maxwell Telescope, radio telescope, on top of Mauna Kea, measured a spectral line in the radio spectrum of Venus, indicating the presence of phosphine. If you look at that image, the black line is the spectral line of phosphine from the Maxwell telescope in Venus. And then the observations were confirmed using the Atacama Large Millimeter Array in Chile. That's the white line, and you can see the dip, the absorption line in the same place there in the spectrum. And that's the phosphine in the Venus atmosphere. Now, it turns out phosphine is a compound that is found on Earth, but it's only created by a biological process in a very oxygen-poor environment. For example, microbes in the gut of penguins is a place where you can find phosphine. The only known chemical process that we know of that creates phosphine that is not a direct result of an organic microbe-type process requires temperatures and pressures that are way outside of what we're seeing here in this Venus spectrum. The belief is that the phosphine is at altitudes of approximately 50 kilometers, where the pressure in the atmosphere is actually less than 1 bar, and the temperature is a balmy 50 degrees centigrade. So, life on Venus? Maybe. But now, I'm going to take a step back for a second. Let's go to Mars for just 1 second. So back in 1976, we launched 2 Viking probes to Mars. And each of these carried a scientific payload that included 4 experiments specifically designed to look for microbial life in the Martian soil. Now, since Viking, we've launched a number of probes to Mars, but none of them had experiments specifically designed to look for life. Most of the experiments on the probes that have been launched since then, and the ones that are still operating today, are looking for traces of water and composition of the soil and stuff. They're not specifically looking for microbial life. The idea being NASA's on the, follow the water, you'll find life. But back in '76, the 2 Vikings actually had 4 experiments looking for life. Some of the experiments were very simple, and some of them were very complex. On both of the probes, Viking 1 and Viking 2, 2 of the 4 experiments returned positive results indicating the presence of active microbes. But the other 2 experiments returned negative results. And as a result, NASA took the position that the 2 experiments that returned positive results were returning, quote, false positive reports, where the activity that they were seeing was caused by some kind of unusual or unknown Martian chemistry. And they let it go at that. One of the interesting things about it is the 2 experiments that returned positive results were the simplest of the experiments. The 2 experiments that returned the negative results were very complex experiments that looked for specific types of microbial activity. The other thing that's interesting is when they took these same 4 experiments and took them to places on the Earth, like the high desert plains in Antarctica and places like that, where they don't expect to find much microbial life, the 2 experiments that returned the negative results on Mars also returned negative results on the Earth. The 2 experiments that returned the positive results on Mars returned positive results on Earth. So it's like, the original project scientists who were involved in those 2 experiments to this day believe the initial results. They still think that they discovered microbial life. There have now been recently several new papers, and several scientists have gone back and looked at that data and have written papers supporting the original conclusions. So maybe, okay, maybe. Now, why is this important, and what has this got to do with the Venus results? Well, when you think about the search for extraterrestrial life, one of the key factors, so you have a number of planets orbiting a star. You have several planets in the habitable zone. They call it the Goldilocks zone, the habitable zone. One of the factors you think about is, well, okay, so you have a number of planets in the habitable zone. What are the odds that life could exist on any of those habitable planets? Well, here you could have a situation where every habitable planet, every planet in our solar system that is in the habitable zone, Venus, Earth, and Mars, might all have microbial life on them. That could seriously change your odds of finding life on other planets if that is something that is universal. If it's that easy to get life, if you can have life on Venus and life on Mars and life on Earth, then you can almost say any habitable planet you find out there might have life on it. And then we haven't even talked about Ganymede or Titan yet, so it could be a lot of it out there. And my throat's going dry. Please forgive me. That is actually the last slide I have. I will answer any questions anybody has.
Yeah, Doug, I have a question. Is there any idea or any theory about why the planet turns in the opposite direction?
The only theory, and it's not widely accepted, but the only theory that I've heard is that Venus was somehow involved in some kind of planetary collision early in its life. Okay, because the other thing I forgot is that it's slowing down. Its day is getting longer by 6 minutes every year. So it's slowing down because it's in retrograde rotation. So it's opposite, the rotation that goes around the sun. And that's slowing it down because of tidal effects. And so the theory I've heard is that it was involved in some kind of a collision early in its life with a very large body, something Mars size. That could cause it to change its spin.
Doug, my theory is it's the only planet named after a woman, so it's going to be right.
That's good.
Thanks, everybody. Adios.
Good night, Vince.
I'm not going nine. I'm going to go saw.
Okay.
You're seeing, I'm sawing.
Interesting enough, in all of those science fiction movies about Venus from the early 50s and the 60s, it was always the inhabitants of Venus were always ruled by a woman. Like Zsa Zsa Gabor in that movie, she was the queen of Venus.
Well, it seems like I read somewhere that, like you were saying, it was involved in a collision, that it actually had the same rotation as all the rest of the planets, but it just got sort of knocked upside down.
Yeah.
So
well, the theory I heard was not that it got knocked upside down, that it literally got the force of the impact was at such an angle that it actually caused it to start spinning in the other direction. I suppose it could have just got I suppose it could have just got flipped over like Uranus had just flipped on its side. Yeah. But that's the only theory I've heard, May, is that it was involved in some kind of a collision early on.
Okay, thank you. So how did it end up in the very beginning to be called Venus and to be associated with females?
Go back to where the Greeks named the planets. They named Mars because that's the god of war, because it had that red color. It's an angry red god of war. Venus is always this pretty yellow, bright. So they named it after a woman. The god
So it
Venus.
was pretty, okay.
Yeah.
So Venus is still up in the morning now, isn't it? It seems like
So
I
yeah,
saw it this morning.
for a little bit.
Venus and the moon looked really good this morning.
Yeah, it was really pretty. There was a crescent moon in Venus. It was neat. So then when does it switch over to being an evening star?
I think later in the year, like December, unless I'm mistaken. Let me check. Let me check something real fast.
So it keeps setting. It keeps setting, rising later, or how does it work? It goes from morning star to evening star.
Yeah, it'll rise later and later, so it gets closer to the sun. So let me just check my latest. So, okay. Venus becomes an evening object in early December.
Oh, so it's just a few weeks off.
Yeah, not too far. Oh, I lost my.
Moon is going to be right next to Jupiter and Saturn on November 19th in the evening. Probably don't want to miss that.
Yeah, that'll be pretty.
That's in December, right?
November 19th.
Oh,
Yes.
really? Okay.
That's the moon and Jupiter and Saturn all together.
Oh, okay. Okay.
A 5-day-old moon, I think.
Right.
Yeah, that's 1 week from tonight. You said November 19th.
Yeah.
Any other questions, comments?
All
I think-
right. Go ahead.
I think that Carl Sagan did predict Venus was going to be quite a bit hotter than would support life before we got there.
Yeah.
I think I've seen a video clip of him in 1962 or something like that talking about how hot Venus is going to be.
No one really knew until we started sending satellites there. People were guessing.
So if they find life, it would just be microbial stuff floating around in the atmosphere.
Probably. That's what the current theory is that there might be some kind of microbial life that are surviving at a very high altitude where the temperatures and pressure are not so bad, that's producing the phosphine. Because that's the only thing they can think of to produce the phosphine. And
but what would it eat?
Huh?
What would it eat?
Well, the compounds in the clouds. There's sulfur and other compounds in the clouds that it could be living off of. You know, there's sulfur, there's fluorine, chlorine. There's other things up in the clouds that microbes could work on.
Okay, if that's that, any other comments, questions? All right. Thank you very much. We'll see you next month.
All right. Good night, folks.
Okay.
Good night.
Thanks.
Thanks, Doug.
Good night.
Great program.
Thanks a lot, Doug.
Thanks, Doug.